Good afternoon, everyone, and welcome to my presentation on my proposed extension of an existing curriculum that I teach here at my high school. Now, I've given this quite a bit of thought, and coming out of a manufacturing engineering background, such as I am, I'm partial to how things get made, not just how they're drawn. And one of the areas that I found a weakness in, if you want me to be quite frank, is that of the Engineering 3 curriculum with respect to manufacturing documentation. So the way it stands right now is you're typically going to be expected to draw an assembly that's consisting of two or more components. So as you can see from this real basic design that I came up with, this is actual in-class template design. You see a cylinder rod that passes through two holes in what we call a rod support that makes up an assembly, like so. And if you notice, this two-part assembly mates quite well due to a design fit between the mating components, and it's welded flush at both ends. This consists of two ballooned items and a listing of them in the title block sheet down below. That's as far as the Engineering 3 curriculum takes it right now. As you can see from this blueprint, we apply, as you see highlighted there, procedures to create working drawings and documentation in support of a 3D model and assembly. We'll look further to expand on that to create sheet metal parts in Inventor, the software package, as well as look at another form of design annotation. But we never go further with this documentation to include how this item gets made. So what I'm proposing is you take that 5.0, which if I expand on it, exists currently just to include what I just showed you in the way of PDF files. Create working drawings, with the assembly drawing, detail drawing, parts lists, and balloons, just like I showed you. And in so doing, create multi-views and annotate the drawings. What if we were to add 3 additional items to Unit 5? And again, it should be mentioned, this is in my curriculum, Trade and Industrial Education, IV 23 Drafting 3 Engineering, which is basically the highest level class you can take in here with respect to mechanical design. Again, as it stands now, 5.0 in our curriculum breaks out to include only that of 501, 2, and 3. I'm proposing we add 3 critical areas. 1, apply procedures to create a bill order of operations. 2, apply procedures to create a manufacturing process plan. And finally, 3, apply procedures to create a control plan. Now, the reason for these 3 additions is simple. I would like to see us be able to cost out and determine how we're going to make each item to include that of the assembly. I would like a visual representation of that bill order of operations in the way of manufacturing process plan. And then finally, if you could tell a manufacturer how much it's going to cost and in what order you want to see this build take place, you should also have a method in which you can inspect or verify that all of the procedures took place in an acceptable manner. So what I did is I went further with it. I said, well, that all sounds good, but now what do these documents look like? If I go to the lesson plan as it stands right now, with just 5.0 as it exists in the curriculum, you'll see it takes 2 days to cover at a minimum. And the 3 criteria, 501, 502, 503, that you saw expressed before, 1, 2, 3, are captured in an introductory fashion within 2 days' time. Again, this is all well and good, but how well will this assess how this particular assembly gets made? That's where this supplemental 504, 5, and 6 come into play with my proposed lesson plan to take a couple of additional days, 3 and 4 to be exact, and apply procedures to create these 3 additional documentation files. And again, I put in my lesson plan, and again, this is just a proposal at this point in time, but it's a good one, I think, in expanding on what we know already and creating drawing-based documentation. Now we're going to create what we call manufacturing documentation to complete a build of that 3D model and assembly. I feel like it's paramount that you understand how something gets made and for what costs if you're going to go to the bother of designing it. So that's where these 3 deliverables come in. A BOO, bill order of operations in support of the parts list, which comes with the territory we've already covered when we ballooned and created a table that made up all the parts in the assembly. But then go further in explaining that parts list to be that of a BOM, or bill order of materials, and how an MPF, or manufacturing process plan, and a CP, or control plan, assist in the eventual build and inspection of this assembly. What that does for us is, again, changes the blueprint slightly. So my proposal would bump 5% of the overall curriculum time in coverage of 5.0, Unit 5.0. Why? Because again, we're taking on 3 additional line items. And we'll look at those in a minute. The BOO, the manufacturing process plan, and process flow, I should say, and the control plan. Where are you going to get that 5% from? I feel like you can pull 5% from applied procedures to create geometric dimensions and tolerances. Why do I feel this way? Because GD&T, as it's otherwise known, is an area that can be covered in far less time than 15% of the curriculum. So this is like a 5% adjustment swing, if you will, in addressing manufacturing documentation, which I think, even though there's a follow-up class to this, not offered here, but in some counties, for an actual machining and manufacturing of devices, it needs to be included in the upfront assessment before we even get to the machining of the part. All right, so that's my proposal. Real quick look at the items that I would be proposing. There's 3, like I said, the BOO, the control plan, and the MPF. If you look at the BOO first, it's quite simply making use of a spreadsheet. We're not talking any additional software requirements here than what's already captured within the student's realm. Really working out of the Microsoft Office suite. I have an assembly order of operations followed by the component order of operations. And not only does it show the order, but it shows the operation hours and the subsequent cost based on a $15 an hour rate. So you can see, and a $15 an hour rate is just, subjective. That's a constant that we use across the board. But what it does is it allows the student to assess his overall cost, which, as you can see here, for this particular item, cylinder rod assembly, comes out to $190. The MPF in the additional item, it's nothing more than a flow chart. It matches that of the BOO that we just looked at. The only difference being these operations are listed in a flow chart type pattern where it shows a pass or reject prior to inspection. And then finally, our control plan, which is essentially another Excel spreadsheet that speaks to the BOO and the assembly and 2 components in terms of what is the operation number, but instead of worrying about how it's going to get made and to what measurement, we're worried about at each step, how's it going to get measured? And that's where you see these highlighted fields right here. This process, how do we measure it? We're verifying basically with this control plan document every step that we've taken in completing the build of this item. Bottom line, in the end, what I'm looking for is the ability to take this curriculum of IB23, Drafting 3 Engineering, and making it such where the student comes away with an understanding of not just how to draw all of these items that we showed earlier with respect to the assembly and components 1 and 2, but how do we make them? And when we make them, what's the critical order in which we go about machining or fabricating these parts? And then the tell-all question, how much does the process cost, both in build and purchase of raw materials? And that's my curriculum extension presentation for today, and I hope you enjoyed that demo. Thank you very much, and have a good evening.